Mike Everets. I'm an architect. I teach architecture as a professor in the architecture department. That's a hard lecture to follow. The one after physics was great. We're doing an outreach in the architecture school with Eagle Mount. And Eagle Mount, I don't know how many of you are familiar with them, but they're a nonprofit organization that does outreach and provides therapeutic recreational facilities for people with disabilities. And we've been helping them with a master plan over the last couple of years. And the last project that we started doing with them is an amphitheater. And before we design the amphitheater, what we have to do is a phase called programming. And that programming in architecture is basically deciding and determining how that space is going to work. And so as architects, we do more than facilitate what a client might give us. What we need to do is design basically the future of what's going to happen. And what we try to help provoke in our space is new activities, things that will happen that enrich that space. But in the architectural profession, the context that we work in is changing dramatically. And some of the statistics that are happening that are showing this or proving this is that space is being used more and more. The space that offices give for employees is shrinking. The cost per employee is rising up. The amount of money that companies are spending on resources, they're spending it on software, not on the physical development of spaces. And as architects in the profession, we're being pushed more from the beginning phases to the latter phases where we work with the contractor on getting the budgets and construction, right? So all of these things happening, what it's doing, it's having, what we should at least be doing is questioning our methods and how we go about doing that in that programming phase. And these are the traditional documents that we produce at the end of a programming phase. So it lists the spaces, their sizes. This is a matrix of adjacencies, their importance, how important they are, but it's deductive reasoning. So it's taking all the information and kind of narrowing it down to what the most critical pieces are. And then you take those pieces, and then in the design phase, you basically juggle them around until they get in the right shape. And as I mentioned in the process, we do this in the beginning of the process before we design the actual built structure. Then we do instructions for the contractor to build it, and then it's used. And that space for programming in the beginning is getting pushed more and more, is being shortened. And it's been shortened so much that it's kind of flipped and it's no longer an area of creativity. And what we're proposing, instead of doing the same thing faster, is to do it differently and do it parallel, not only to design, but also to the occupancy of the building. So as an architect, you can stay engaged with how spaces might change and then develop them in a resource-efficient way. So the first thing is to not think deductively, but inductively, and to think expansively. And the way that we're doing that is not only thinking of programming as a use of what that use is, but thinking of the infrastructure that's associated with it and the human resources that are associated, right? There's people that, even with this space here, that like Ilsa's doing, that manage it, right? Bring everything together, and that's an important part about how all this works. And so what we're doing is we're developing a visualization software to think inductively about what program might be. And we're right in the early stages of kind of prototyping and scripting it and testing different things with it as we're doing the design of the amphitheater for Eagle Mount. So it's a little bit rough right now. What we're basing that visualization on, though, and I'll show it again, is a theory called semiotic square that was actually developed in 1968. And what it does is, instead of being deductive, it's a way of thinking about things inductively. And so if you take this diagram here, I'm going to use as an example a very basic binary relationship, man and woman. So if you think of man here, woman here, and not woman here, not man here. So that's a contrary relationship. So man, not man might be an effeminate man. Not woman might be a mannish, right, woman. between man and woman, the idea of androgynous, right? And so what it does is it starts to expand the way you think about things. So instead of 2 things, a binary relationship, all of a sudden you have 8 and a whole gradient in between about how you think of things. It's been used in business basically for, portfolio analysis here, where they put stocks on that type of semiotic square and analyze the relationship and how they're performing against each other. And so this is just a summary of what we're using, what we're basing that visualization on, starting with the theory. One of the things that brings up is that that's a 2D graph, right? And we're talking about meaning of how you're analyzing terms. We're dealing with architecture, which is basically the reification of a concept. And reification means to make solid something that was abstract. And so in architecture, what the actual environment is needs to have a certain readiness of context to be engaged by that new meaning that we're projecting on it. An example I'll give you is the flipped classroom. Probably a lot of the maybe some of the classes you're already taking are using this pedagogy, where you learn the lecture before you come to class, and then in class you have very dynamic activities that are in big groups, small groups, you're at different points in the lesson, very dynamic. Right? This is actually, I think this is in Danes, right? One of the teal classrooms. And you can see how it's organized, right, with the different groups, and so it can combine in different ways and show all the technology. But if you look at this image and you take away all the screens, you take away the tables, basically you come up with the same box, the same as it ever was. It's the same classroom. They haven't changed the physical space to keep up with the technology. They're relying on just technology to do the things that space could help do. So Princeton just finished last year a two-year study that they did on this phenomenon. Is the physical space working for the pedagogy? Has it kept up with the flipped classroom learning? And it hasn't. And so one of the suggestions that they determined was that you need to involve the opinion of more people in the space. And there's a lot of technologies to track what's going on of resources. So not only could it doesn't have to be limited to that one room. You could find out, you know what, there's a classroom across the hall that isn't being used right now. One of those groups could go over there and use that. And so we've based some of the development of our program on some of the ideas that they came up with. And so we're integrating monitoring of use. So as a space is being used, you monitor its use, see what's being used more, and maybe that's something then you could elaborate on as a space develops. Also, the performance of resource. Remember I showed that diagram where it expanded into the infrastructure and human resources. So when you link that in, there's obviously a lot of tracking software available now to see how that's working. And we're just linking those things together and see how they work as a system. And then finally, developing spaces that can do that. It isn't that square box for that classroom. That can't do what the technology is suggesting it might be possible to do. So this is where we ended up. This is a site plan of Eagle Mound. And when we first started programming, we ended up with that same deductive list of programs. We need this many spaces. These are the sizes. These are their relationships. And what we come up with is that, right? When you think of amphitheater, outdoor amphitheater, you think of that. And as we talked with Eagle Mount, that just wasn't like that amphitheater. It was more like the example I gave of the flipped classroom, something that was very dynamic. They're working with a clientele that is getting better at something that they're doing in a whole kind of evolutionary environment. And so we wanted to design something that was closer to the mission of what they actually do. And so we took terms, and what's important on this is we took them with regards to space that we have, with regards to the use, and human resources. So we're starting to analyze these in an inductive way, right? Think expansively about how those different resources in use might be interpreted. And that's the contrary and then the contradictory, and going through that. And then in the computer, and these are screenshots of that visualization. So we're taking that 2D diagram of the semiotic square, and we're putting it in a 3D environment right now, and then a 4D environment. And so space, semiotic squares on the top, the performance is here, and if that performance is based more on space or human resources, it can slide up and down, and then we plot what that is. And the other thing and then this is the kind of behind the curtain, and probably for the computer programmers, this is pretty remedial, but for architects, this is pretty advanced. So this is Grasshopper, and basically it's visual scripting. And so it's a way to visually see and script in a pretty intuitive way some of those things we're doing in the visualization. And then the blue, this is plotting those actual relationships that we're starting to visualize. And the important part of that is it changes over time. And so we're making a prediction here, you can see over months, of how something might change. So for example, this is the human resources semiotic plane, and maybe you start an activity where it needs a lot of hired people. And for Eagle Mount, at least, that's a big deal because they operate on a pretty low budget, and every bit of money, right, means a big difference. And so they might start a program with having a lot of paid resources, but maybe it's something that either volunteers could start doing after they learn how things are done, and things could shift a little bit, and then help economically with how that space is used. And so this is a prediction, and then the idea is we monitor whatever got designed, and then go back and adjust it. So if you think back to that diagram I showed where programming is continuous, this is part of the activity where you make a prediction and then you gauge all along its use and develop it in an appropriate way. And so these, again, are just screenshots of kind of where we are now with integrating those things so that you can see them. After that analyzation of thinking of the meaning, it's got to get to a space, as I mentioned before. So the step before the actual space design of what the structure is doing diagrams of different relationships. And one of the things that we started to explore was the idea of the path. So maybe instead of an amphitheater where the audience just sits around to look at one activity, it's a series of paths more like a park. And so if you think of these diagrams, the analogy of a park, it's designed right with slopes, there's trees, all these different kind of environments, and they aren't programmed or scripted. You don't have to do this, there, this, right, this other thing in this spot. You have the opportunity, but there's also a tendency for you to, right, you don't go throw the frisbee for your dog in the trees, or maybe you do, I don't know, right? They need a space to run. And so if you look at a park, just because of the topography and the way that it's designed, it tends to attract certain uses more than other uses. And so this then is kind of where we're at with that programming phase. So you can compare some of the things that we're doing here, some of the things that we're doing here with regards to that traditional programming. And this would be an example of the inductive thinking. And then the final step here is, and this isn't the design, this is just the diagram. We're right now at the design part where we're jumping into that. Picking places where we need to monitor the activities, right? Strategic places so we can develop in the future. This stuff is just becoming, this approach, something that we can actually do now. Although they have software for tracking human resources, they're just now developing a lot of real-time tracking software with GPS. And so you have building fingerprinting, magnetic fingerprinting that's being integrated into Google, tracking real-time of activities. And all this allows us to kind of think differently about program because you have the different uses to that. So that's where we're at right now as far as simultaneously developing the software on inductive programming and starting to develop the actual amphitheater for Eagle Mount. Thank you very much.